Hello and welcome. Today we're going to be talking about continuity and behavior and limits, part B. So we're going to be talking about using something called the location principle today, as well as talking about end behavior using leading terms and other things, or just looking at graphs. So the location principle, this is something that you'll be using in calculus. It's very heavily related to something called the intermediate value theorem, and you use this with derivatives in calculus at some point. And you'll see that later, but we do need to walk through what this is. The location principle is some sort of concept or useful concept in algebra and calculus for finding the roots or the zeros of a continuous function. So the key thing here is that it has to be a continuous function. Therefore, we can kind of locate the zeros, the roots, the solutions where it crosses the x-axis, those x-intercepts. So if a function is continuous and the sign, which is is it a positive or negative value, if we plug in the x value and find the output, what is that is the sign. Changes from positive or negative positive, then there's going to be at least one real root or one real zero at that interval. So for example, if we have f of x is x squared minus 4, if I plug in positive 1 to this function, I will have a negative value. Now if I plug in 3, I will have a positive value. From negative to positive, it has to go from negative to positive, so it's going to cross 0 in between. So it's going to be something like this. If you have here, if we have a negative 3 for my y value at positive 1, so at negative 3 here, and at positive 3, which is right here, it's going to be at 5. So it's got to somehow connect through here. It's going to connect somewhere in between there. I don't know exactly where between 1 and 3, but it has to somehow cross that x-axis. It can't just jump without passing this because it is continuous. Continuous means it has to connect and flow nicely. So it just can't avoid that x-axis line. So it's going to cross somewhere there. So what we're going to do is our first example is we're going to kind of like make an XY table just like the section part A before, but we don't really have to write in the actual Y values. We only care about the sign of them. So we're given the function f of x is x squared minus x minus 3/4, and we want to figure out where are those zeros going to be located on the interval from -2 to 2. So what we first have to do is, well, we're going from -2 to 2. That's including -2. And we're going up by consecutive integer. That means nice numbers. So -2, -1, 0, 1, and 2. So the consecutive integers and this interval tells us we're going to be using those values. Now all we have to do is just substitute those values into this function, and we could write down the actual value, but I only really care about is it positive or negative. If I plug in -2 to this function, so if you think about it, we have x squared minus x minus 3/4. If I substitute in -2 for this, this will in fact be positive something. I don't know what that something is, but it's going to be positive. Because this will be 4 plus 2, which is 6. 6 minus 3/4, which is 5 1/4 actually. So it's positive 5.25. We just need to know it's positive. Also, if we plug the -1 in, this will also be positive. If I plug in 0, these go away, and we're just left with -3/4, so this is a negative. If I plug in 1, it's also going to be negative, and if I get back to 2, it will be turning to be positive. So I am specifically looking at the sign changes, not the values. So I just care about what's in front of the number. So is it a positive number or is it a negative number is the biggest thing here. Now, what does that mean? Well, notice how it goes from positive to negative here and goes from negative to positive here. So that means by this location principle, there has to be a 0 somewhere in between both of those places. So what we're going to write down for my answers, there are zeros between -1 and 0. So we have it between -1 and 0 here, and we'll have it in those intervals where we're not including the endpoint. So it's not at -1, it's not at 0, but it's somewhere in between there that I don't know what it is. And it's going to be between those two, between 1 and 2. Those are not points. Remember, that's interval notation. So that's that interval with a not inclusive bracket. So another example, again, I put this in already. We're going from -4 all the way up to 4, and it's consecutive integers. Just means we're going up in order from -4 to -3. Consecutive is one after the other, and integers means those nice numbers, both positive and negative. And then we just have to make sure we plug those into this function and see what we get. Is it positive or negative? You are allowed to type this into your graphing calculator and use the table function. So if you are interested in using the table function, you can do that on the TI-84, and that will actually give you all of those values. And you can notice that it's going to be negative value, a positive value, a negative, goes back to positive, and positive. Now it goes from negative to positive here, positive to negative here, negative to positive here. Therefore, there are zeros between, we're going to go from right here, so -3 to -2. We're also going to go from here to here, so -1 to 0. And our last one, which is right here, which is 0 to 1. So let me move that up, and we're going to go from 0 to 1. So those will be where there'll be 3 zeros. There has to be, because this is a continuous function. It is a polynomial. If you remember, we talked about polynomials. They'll always be continuous, and they never break. So that will be your answers. So please try this one on your own. See what you can find. I will have an answer shortly after you pause it and try it. So you should have got a 0, one single 0 between -2 and 1 if you did the table and tried it. Again, to do this, you'll have to do the table to show me your work here, and then you'll have to clearly state that.